Okay, so we're gonna take a little shop tour of Nolan's D&D Plastics. We're bending plastic. We're gonna vacuum it into a round dome, just like that. So this is all about our journey to ElectraFly and building the machine that will actually fly and carry people, and our intermediate steps of building our smaller machines that will lead us to our bigger machine. And so by being here with Nolan, we're able to look at the processes that could potentially be used to create a canopy. So we're here with Nolan in a very noisy shop at the moment, and we're talking about this big heat press machine. And where did you get it?
Out of Detroit. It was making seats for the Toyota Tacoma, the vinyl seat cover.
And now you're using it to mold all kinds of plastic.
Yeah, probably this month we'll have around 15 different items that we'll mold on this machine.
Wow, that's awesome. All these different kinds of plastics, how do you cut them? What kinds of bits do you use? What kinds of cutters?
Well, it's mostly like a wood shop where we have, a table saw or a panel saw, router with different type bits that we use to cut the impression or groove or whatever to trim a part out.
So are they abrasive bits? Are they spinning bits, or are they like sanding it,
Most of our routers are stationary, set in a table so we can move the part around it. It's a carbide, a really high strength carbide bit that we cut parts with.
Oh wow. So these teeth are coated.
Yeah. They've been sharpened and then they put that coating on them.
Okay, so you don't leave the coating on when you use the blade, right?
No, it comes off. It's just really a really soft material. Comes off of there. So.
Wow, and that's not a wood bit, or is it?
This is special for acrylic.
Oh.
Especially for plastic.
Wow. Stuff comes out of the mold. It's basically a finished product. You were telling me off camera here that there's really not much sanding you want to do or anything like that as part of your process, because that can be very labor intensive. Is that right?
Yeah, that's correct. You want a finished part so you don't have so much labor in it. So if you're sanding it or painting it after a while, it increases the cost a lot.
And what's the process if you do sand it?
It depends on the product, depending on how you're wanting to sand it or how polished you want it. If you do much sanding, you know that you have to start with a real fine, coarse grit, and then you work up to a finer grit.
Okay. So you're just pulling off material very slowly with very fine grit sandpaper, progressively finer.
Yeah. Sometimes with acrylic, we'll get an aquarium like this. That's a 180-gallon aquarium. And sometimes we'll have to polish it up. It'll get like a nick or a scratch in it. And we'll start with about a 360, maybe a 400 grit, and then work up to about a 3,000 in different stages.
And so for our purposes at ElectraFly, our main interest is kind of forming and shaping a compound shape, a canopy of sorts. And can you tell us a little bit about what that process would look like?
To make the canopy?
Yeah.
The canopy, for low production, we would make a mold out of like an MDF, make that shape, and then line it with like a felt, so that when the acrylic or polycarbonate would rest against it, it would keep the surface fairly smooth.
Okay, so it starts with a mold, and then we control the shape of the mold with the felt. And I guess we would be vacuuming that into the mold as well, is that right?
Yeah, we'd use a vacuum to suck it down into the shape.
Okay. So you just loaded it at the loading station,
Yeah.
and now you've turned it, and now it just went into the heater.
Yeah, in about 80 seconds it'll be ready.
Okay.
We can control each of those tiles separately.
Okay.
There's 80 on bottom and 80 on top.
Okay.
Swing from there and around over to here.
Okay. And then this is the vacuuming station. So you've got a mold down here.
Yep. This is a free form, so there's no surface for it to touch. So
Right.
it's a free air.
Uh-huh. So the air chooses the geometry.
Right.
The only thing that's controlled is that circular hole at the top,
Yeah.
the oval hole. And here it comes. We can see it kind of sagging there because it's hot.
Yeah. It takes about 80 seconds and it cools down. You'll see it start to turn kind of a white back to the color it was. And then it'll be cool enough to pull it off the mold and go to the next station.
So it sucks down for a period and then it just stays, it just holds that level of suction, I'm guessing, right?
Yeah, holds that shape.
Okay.
Yeah.
It looks like we have a cooling fan blowing on that as well, is that?
Yeah, cooling fan in certain areas for it to be cooled.
Okay. Right around back to your loading station.
There we go.
That's amazing. We just made this this cool shape here, and one thing I've mentioned is that you were the inventor of laser tag, right?
Yeah.
Can you just tell us about that for a second?
Yeah, in 1983, my classmate, Lance Ensign, him and I had an idea of doing laser tag. So we started with a flashlight from Kodak first that was focused. And then we worked up to the actual laser. But the lasers were too strong, so we had to work with a professor out of BYU to pulse that laser so it wasn't strong.
And now you don't live all the time here in the U.S. You travel the world. You live in a lot of different places. You do a lot of interesting things. Can you just tell us a little bit more about you?
Yeah, so about 10 years ago, I moved to China to do plastic and a global supply chain management company. And, you know, we do every type of item there is. We do the metal, we do fabrics. Not so much fabric, but a lot of plastic. A lot of plastic items. And I have employees there. I have special factories I work with. And I have an office in Manila, the Philippines also.
That's amazing. Now for the final step here, we'll take this piece and go trim it. Okay, so our thought is what we can do with D&D Plastics is, well, we started because we need something to protect us from just shop debris. You know, we're close to spinning motors and we need to have protections around those things. And so we used a 1/4 inch polycarbonate. For those of you who don't know what polycarbonate is, it's not plexiglass. Plexiglass is brittle, would break, and it wouldn't protect you from anything. Am I right on that?
Yeah, it protects you a little bit. We can get a piece of it and hit it, you'll see the difference.
Okay, so we're going to put these two things to the test, and Nolan has graciously offered to sacrifice a couple pieces for us. So here we go. Sacrificial piece of plexiglass and our sacrificial piece of polycarbonate. And of course, safety first. Thank you. In order to test these things, we've got a full-size hammer, so that ought to offer us some pretty good protection if it can protect us against something like that. And we'll give that a shot. So we're gonna have to start with the plexiglass here, right?
Sure, whichever you want to do.
Okay. That didn't take a whole lot. Okay. So sad. All right. So this is polycarbonate.
Right.
The plexiglass didn't hold up too well. Try and step this up a bit. I think we're going to be pretty safe. I think we're going to be all right.
You think you'll be all right? Okay.
Wow.
Did it scratch it?
Look at this. So, we don't have any plastic on this still, right? No plastic coating.
No.
And there's like a slight deformation there, but that's about it.
Yeah.
That's unbelievable. Wow. Thank you.
Yeah.
So, for those of you at home, please don't try and protect yourself with plexiglass. I'm just walking around the shop here and come across this in a box. What the heck is that?
These get glued to that fluorescent plastic. It's a sanding tool for people that do auto body.
Oh, really?
Yeah, so they want to be able to flex a little bit.
Uh-huh.
And they want different colors so they know how stiff.
Wow. Wow. So how do you bond them? How do you bond the edges on any of these things?
We use a special acrylic glue, polyethylene, and the glue won't affect it.
Really?
Yeah.
And you're applying it in that little needle applicator.
Yeah.
And I can see how like viscous it is. It's almost like water in there.
Yeah.
Wow.
You apply that to the plastic, and then it melts it, and then it bonds back together. And when it bonds back together, it cross-links tighter than the original material. So most of the times your glue joints are stronger than the original material if it's done properly.
Wow. Is there any other post-processing that goes into that?
Not with this item. This is a finished item.
Okay, so just before I am leaving here, I am asking Nolan, is there any kind of good environmentally friendly plastics out there? And this is what he has to show me here.
When I was over in China, I was asking them about some eco-friendly plastic that they're coming out with. And this material for this cup is made out of a bamboo and some other resins that will over time break down, and it will turn back into earth.
So it's bamboo
Yeah.
based. Mm-hmm. Yeah. And it says it's dishwasher safe.
Yep. So you can wash it and then it'll dry, and then it won't break down. But as it stays in the soil, it stays moist, and then the bacteria, it'll break down over time.
That's amazing.
Yeah, it's really amazing.